Question is, a cord of negligible mass is wound the rim of a fly wheel of mass. So mass we have 20 kilogram, radius we have 20 centimeters, so 0.2 meter. A steadily pull of F is equal to 25 Newton is applied on the cord as shown in figure. The flywheel is mounted on a horizontal axle with frictionless bearings, right? So A, compute the angular acceleration of the wheel. So angular acceleration means alpha, right? So formula is tau is equal to I alpha. Now what is tau? Tau is equal to RF sine, here 90 degree, sine 91. So R is 0.2 into 25, right? So that will be 5. So tau is equal to 5 Newton meter. So we need to find alpha. Alpha is equal to tau 5 upon I. Now we don't know I. I is equal to mr square by 2. So m is 20 into r square. 0.2 into 0.2, 0.04 upon 2, right? So that is 10. So 0.4. So here it will be 0.4. So 50 upon 4, right? So 50 upon 4, that will 12.5. So 12.5 radian second to unit, that is our alpha. Find the work done by the pull when 2 meter of the cord is unwound. So work done, right, that formula, work done is W is equal to tau into theta, right? So see here, all values we have, we can write directly work done formula, force into L. So force is 25 Newton and 2 meter, right, 2. So 50 joule is the work done to pull when 2 meter of the cord is unwound, right? Then third, find also the kinetic energy of the wheel at this point. Assume that the wheel starts from rest. So see, kinetic energy of the wheel, that formula is K is equal to half I omega square. Now we know that I is equal to 0.4, but we don't know omega square. So final is equal to initial plus 2 alpha theta. Now the object start from rest, so omega 0 will be 0, right? So theta is equal to omega square upon 2 alpha. Now omega square, now we don't know omega square and alpha earlier we found that, right? So here by putting these values of omega and alpha from earlier, we will get theta, right? So actually here we have to find omega square to put this in this equation. So omega square that we have to subject, so 2 alpha theta, right? So alpha earlier we found and theta also we found. So omega square we will get, and by putting in this formula and I, we will get rotational kinetic energy in joule. And the last one, compare answers to parts B and C. See here, work done by the pull is equal to kinetic energy of that object, because here no loss of frictional force. So if no loss of frictional force, then total kinetic energy will be converting into the work done by the object, right? So or we can say that work done by the object is completely converting into kinetic energy, there is no loss.